Hello, everyone. Rashad, man, the big words on the screen are starting soon. Not go home, man. Come on. What I gotta do? I know it's a couple minutes late. I apologize. I'm here. Look, I get that. It's stressful. Nobody wants to work right now. And it's kind of a weird double-edged sword because I feel like if you have to work from home, had a good nap, I took a shower. It's not really the same thing, though. I did take a morning off, and let me tell you, I needed it. I'll tell you about that, why I needed it, because it's relevant to the class. But for now, the short answer is no, I didn't take a nap. I took a nap on Sunday. That doesn't count. I did take a nap, which is unusual for me. I don't normally get to take naps. And truth be told, I have not been getting enough sleep. Again, I'll get to that. Okay. Let's get into announcements. Just a reminder, I feel like I need to say it because it's come up. Now, I'm sure it's not the folks of you that are here and on time. You're not the ones having this problem. But just as a reminder, if you're not sure what's to come, take a look at the announcements. Content, syllabus, and announcements. Announcements. Here is where you can see your summary of what's to come. I'm pretty good, Antavis. I needed a little bit of a break today, so I didn't come into the office until about 3:30, and I needed it. And I'll tell you about it because it's relevant, like I just kind of alluded to. Okay, it's not about deserve; it's about needing, and that's the thing about mental health is if you don't preserve your, you can look at it like your sanity, what people used to say, like, I'm going to go insane, Well, for me, it works a little differently, but I worked really hard this weekend. The exam that I ran for the undergraduate class, the 368 class, my stats class, was complicated and was apparently too much for me to expect students to understand. I didn't think it was that complicated, but, everyone's got a lot of new to deal with, and it was just a giant hot mess. And so I spent my entire weekend dealing with that, like putting out fires, And I'm not trying to say anything bad about it. Like, I get that everyone is in, some form of panic mode. Or maybe there are people who are just bored out of their minds, but most people are, really overwhelmed right now in some way. Emotionally, logistically, something. So I'm not trying to be critical, but I worked until like 3 a.m. on Thursday, and then I got up at 9:30, and I worked all day, and then I worked like half a day on Saturday, and then I worked half a day or a full day on Sunday. And it's like holiday weekend, and yes, let me fix that. I don't know why my brain doesn't do as well with so I have Monday, Wednesday classes, and I have Tuesday, Thursday classes, and my brain does not do well at switching back and forth. You're absolutely right. And what's weird is I get it right sometimes. Like, I did Thursday here correctly, but I did both of these wrong. Any more that I missed? Save. Caramel flavored. Yeah, that was basically me after this weekend. I was starting to lose it. So I needed to take a morning off, go outside, not think about work or emails for a couple hours. I needed it. All right, so there's just I just don't have time to do chapter 9 videos. I haven't had time to. It feels like I don't even have time to keep up with the semester as it's moving on. It's just been awful. And again, mostly that was this weekend. It was the exam. It did not go very well. I still think the theory behind it was good. Students just were not ready for it. So the worst part for me emotionally was that several of them blamed me for that they failed to take advantage of the things that I gave them, and that was my fault, that they didn't do it. They didn't do what I told them to do. So that was really frustrating and really draining, dealing with several people in a row having the same issue. It was really frustrating. So all I have to say is Chapter 9 assignment videos aren't happening. So yeah, and I know that. Like, I do everything that I can, and there's I can improve. Like, I've got room to grow, but I work hard to communicate well and clearly and effectively, and there's just, it's hard for everyone to stay on top of things right now, and I get it. I get that. What I've told several of my students is that they're treating me like an enemy, even though I'm your teammate. And it doesn't need to be a conflict. Like, help me work with you. Don't work against me. Anyway, so here's what matters. We don't have time to do the Chapter 9 thing because we need to be moving forward. Appreciate you, Aunt Davis. We don't have time to be working backwards on Chapter 9. I'd love for us to have time for that, but we don't. The reality is, counting today, we have 4 class periods left. 4. We don't have time to worry about Chapter 9. So I put you a bullet point right here. Don't worry about the Chapter 9 assignment. It's just not going to happen. So here's what I'm going to do. I'm going to find a system. I'm not quite sure what the cutoff is going to be. No, it won't be. The final exam, it's not cumulative. So it'll just be, it'll be just chapters 10, 11, maybe a bit of 12 and 14. I think we'll do. I'm not even sure if we'll do 12. We'll talk about it. I'm more worried about 10 and 11, but 14 is pretty good too. So we'll see. We'll see how far we get and how things go. So all this to say is I'm going to find a way. I have an idea of what I'm going to do, but I need to think about it and make sure before I announce it. I think I know what I'm going to do. But basically, I'm going to draw a cutoff on the scores. And if you did at least the cutoff, then I'll give you a 100 on the assignment. And if you do below, if you like didn't turn it in at all or got below the score, maybe the cutoff will be 0. And if you turned it in at all, you get 100. And if you didn't turn it in, I'll just exempt you. I don't know. But something like that. So basically, some people will get hundreds. Everybody else will get exempted. So no one will be harmed by the assignment. But if you did well, then it'll make you, if you did well enough, then I'll bump your score up for it. Is it multiple choice questions for the exam? I'm still trying to decide what I want to do for the exam format. I spent a whole bunch of time arguing with myself and actually discussing with other people what I was going to do for the stats exam, given that it's online. And this exam format that I came up with for the weekend is the best thing that I could come up with. And like I say, a lot of people were really upset that I gave them flexibility on about when to take the exam. They were upset that I let them break it into pieces and take it in several chunks, and it was just unnecessarily complicated that they got to choose if they wanted to take it in pieces or not. So I don't know. That's what I said. Yeah, that's what I said, and they're like, no, that's just dumb. You should make us take it all in one chunk. I'm like, then just take it all in one chunk. I'm not saying you can't. I don't know. Whatever. So like I say, I've got to do some processing. I got to do some processing on what I want to do for the format, so I'm not sure. We have access to MindTap, and I like the fact that you can just check your work and you can get it fixed and resubmit it, so you get the right answer. You cannot do that in D2L, which is kind of the issue. It's part of what led to the complicated format that we went with. Is I don't have the flexibility to let you try it multiple times without submitting it and starting over. So I'm not sure what I'm going to do. I'll tell you as we know more. At this point, I'm not sure what the rest of the to do is. Well, it's totally different, right? What we're doing is totally different. We haven't done anything like Chapter 11, for example. I know Chapter 9 MindTap was a disaster, and that's not your fault. It's also not MindTap's fault. It's just out of date. It's out of date now. So it made it harder than it would have been. But it's out of date, which, I mean, I'm not saying it's not MindTap's fault, that it's more like the textbook is out of date now because the tutorials are out of date, and so the questions become hard. the chapter 11 stuff should be a lot easier, or even chapter 10. Chapter 10, chapter 11 should be easier, just because Solver hasn't changed any. So hopefully chapter 10 is going better. But speaking of chapter 10, I realized this earlier this afternoon. I didn't actually put in a deadline on D2L. On MindTap. So yes, I said it here, but it doesn't show on the calendar as being due, which is unacceptable for my standards. So if you haven't already done it, I will extend the deadline to Thursday. So you've got 2 more days to work on it. So I apologize. My mistake. It's in there now. Thursday, I will... Yeah, like I said, it wasn't in there. The Chapter 10 assignment on MindTap, I had it in as practice instead of as a required assignment. That's why it was... That's why I'm extending the deadline, just because if you didn't realize that was it, that's not... I totally understand how you might get confused by that. So I have made a Chapter 10 assignment actually required now, so it'll show up in your calendar and whatever. So, sorry about that. I will give you Chapter 11 assignment on Thursday. Chapter 11 is just Chapter 10 with extra steps, and that'll be due next week. And then I might give you a quiz over Chapter 11. I had originally planned to, but it would probably just end up being like another MindTap assignment. So I'd be doing it largely so that you could have more things in the grade book, which is worth something. But I'm also not sure it's entirely worth your time. So I'll keep thinking about this, and I'll let you know. Unfortunately, I need to do thinking for your class, and my last week has been totally consumed by 368. I haven't hardly spared you guys a thought. Like I've wanted to, but I've just been at my limit and past it with 368, trying to get all the stuff figured out. So I'm really sorry. So 368 is is taking a back burner, and I'm gonna work on. You guys have my full attention for the immediate future. So obviously quizzes are a burden for everyone. However, they provide a buffer, so to speak. The more assignments that you take, the more a single the less that a single bad grade affects your overall score negatively. So generally having more assignments is better than having fewer, or it's at least a lot less stressful. One option that I'm considering is that I will give you a quiz like next week or something, and it would be like a spreadsheet modeling quiz. It would be over 10, 11, and 12. And then during finals week, if you wanted an extra quiz, you were saying to yourself, oh man, I didn't do well in quiz 1 or something, and I wish I could replace it, then maybe I'll offer you guys a third quiz. If you don't want to take that, you can just drop the third quiz and it's fine. Or I can let you take the third quiz and then average your scores out. Or, if you want to take it, you can, but you don't have to. Because it's during finals week, it would be, an extra. I don't want to make you do it during finals week. You already have more than enough to worry about. So I don't know. I'll let you know. Again, I got to keep thinking about it. I want to do a Chapter 11. Okay, 2 votes for approval. Yeah, it seems reasonable. I'm going to do something similar for my 368 class. I will potentially So originally you're supposed to have 3 assignments and all 3 were going to count, 3 quizzes and all 3 were going to count. And then, so historically, what I've done with my classes is I tell you guys, you better get all 3. You're going to need to do all 3. And then at the end, I offer, if you meet a threshold of the student evaluations, then I drop one of the quizzes. So that is usually what I do, is I kind of give you an incentive. It's not a kind of incentive. It is an incentive. Fill out the surveys, and I will drop a quiz. So it may be that I just exempt the third quiz for everyone, but if you take the third quiz and we get the threshold, or maybe I'll say, yeah, you've got a quiz to take unless we get the threshold, and then everyone's got to take it until we get the threshold or something like that. So I'll let you know. I'll think about it. Last thing is, before we get moving, we need to move on. Chapter 11, vocab, there are a lot of words in Chapter 11, and I looked at it briefly about cutting some of them out, and there's a lot of words that I want you to know. There might be some things we would cut, and part of it depends on what we get to cover in Chapter 11 this week. I'm not sure how much we'll get to include. I'm hoping, basically all of it, but we'll see. I suspect that we won't get through the sensitivity analysis part, which is disappointing. But in that case, we could take out some of the sensitivity analysis vocabulary. But there's like 25 or 30 words. There's a lot. So I'm going to cut down the list into 2 pieces and probably take out some of the words entirely, and I'll put that on D2L this afternoon, this evening after class. So I started looking at it, but I haven't actually finished the list, so I'll get it put up. When we get your midterm grades, when I get to grade them, I have tried to pick deadlines, and I get to it when I get to it. This has been a very difficult thing, and this whole coronavirus situation is a nightmare, and trying to sort through it is a giant pain, and no one knows what's happening. So things keep changing, and it's been very difficult. And so all I can say is I get to it when I get to it. I mean, again, finals are in 2 weeks. So obviously you need your grades. I understand that. You need your grades. I totally get it. I'm not sitting around bored holding out on you, I promise. Well, the joke that I usually make is the longer I take to grade it, the less critical I can be. So, pros and cons. How's the virus where we are? I mean, it's generally fine. Tennessee is I thought you wouldn't mind. So the Tennessee is not it's not actually the least affected state, because the least affected states are the Midwest, the actual Midwest, not Illinois, but like the Dakotas and Wyoming, where nobody lives anyway. Those states have very few cases. Knoxville would actually be, Tennessee would be pretty low as well, but Nashville has a bucket load of cases, so they're making our state look bad. But I think we have a grand total of like 150 cases in the entire part of the state. So, so Knoxville itself is not bad at all. But my mother did invite my aunt for Easter dinner on Sunday, and she works at the hospital, one of the major hospitals, so hopefully we didn't all get exposed. I had a conversation with my mother about it, and she was like, yeah, but it's Easter. How would she feel if we told her that she couldn't come for Easter dinner? And I'd say, probably not that bad when you say nobody is allowed to come to Easter dinner. But no, my mother would not consider that argument. Did she shower before I hugged her? I don't know, because I did not hug her. And I'm not apologizing for that. But we're hanging in there. Hopefully everybody is doing well. I know a few of my students, at least 2. Hey man, I'm doing it. I'm embracing that. Social distancing. Yep, you know it. What was I going to say? I had something else important. Oh, I was just going to say that I think 2 of my students, and not in this class, I think 2 of my other students have tested positive. A couple others have family members that they're living with that have tested positive. I didn't give you Chapter 11 slides. That's not very helpful. Let me get this uploaded. And I'm going to need to give you 12. I actually haven't even edited 13 and 14 yet. Okay. Let me download. Preparing the document preview. I really don't need that, actually. If I could just have the slides, that'd be great. I'll go ahead and put 12 up there as well. I need to make the other 2 I have slides. I just need to edit them. They don't come in these, so like this NEIU slide template, for example, they don't come like that. So I do get these in a raw form, and then I like make them pretty and edit them and do other nice things to it. So, okay, so last week we dove headfirst into the basics of spreadsheet modeling. So I call it the basics. Truthfully, we covered, I would say, like the mediums. It's not quite the basics. It's not really the advanced. It's, some of the moderate difficulty. We didn't talk about the true basics of spreadsheet modeling, but we talked about some functions, some product functions, and things like that. So today we are upping the ante a little bit, because before we said, we want to know what happens if I plug in a particular value? What's the outcome for that? But we didn't do anything, partially because we skipped some stuff, but we didn't do anything that would actually tell us what a good decision would look like. We simply provided the context in which we could answer the question of what a particular decision would result in, which is, of course, the first major step. Whoa, wrong button. Sorry, folks. There we go. Okay, so that way my head is smaller and not covering the slide number. Okay, so today we begin our journey into optimization problems, which is really is pretty much the bread and butter. It's the core concept of my education. So if you haven't heard me say this before, my degrees are in operations management, and if you had to summarize that in like a sentence, it's finding optimal solutions to business problems. That's basically what we do. Optimal meaning the best. I like to quote the Foo Fighters, and like it's the best of your options, basically. Not like just a pretty good one, but like the absolute best option. So we call these problems optimization problems. The idea of we have some question, what is the best budget allocation subject to these restrictions? This kind of idea. That is an optimization problem. So the idea is that we're going to be supporting with data and theory managerial decision making. The idea being that we can make better decisions through the use of software tools, that we can better understand our problems and how to solve them most efficiently. So there are two major components to an optimization problem. Number one, we have an objective function. So that's the two things in bold. Number one, the objective function, which is basically is what you're worried about. So in an obvious case, first example problem that comes to mind is a finance problem, where it's like a budget allocation problem or a portfolio mix problem, where I want to do what? Well, there's two ways of looking at it. With investments, you either want to maximize profit or you minimize risk. So you have these two offsetting issues. You have these two offsetting things. So generally speaking, if you have a series of good investments, the ones that make the most profit will probably also be the most risky. And so you have to balance expected profit versus expected risk. And so you either have to limit your risk, like set a restriction, like I don't want any more than this amount of risk, and then you make the most money you can without exceeding that. Or you say, I want to make this much money, and then you minimize your risk. Like this is my target growth, and I want to minimize my risk subject to that growth rate. So you have these two ideas. You have the goal, and then you have the restrictions. So let's say if you say I want to make the most profit possible, then your profit is your objective function. And then you're going to say subject to an acceptable level of risk. And so that is your constraint. Your constraint is an acceptable level of risk. Your total risk in the portfolio has to be this or lower. So then that is your constraint. So the process of optimization modeling is to define, at least verbally, and understand in your head what the objective function and the constraints are, and then put them into a form that your computer can recognize. Now, it's important to understand that your objective function, your constraints can be linear or they can be non-linear. And it's very important to understand the difference. Obviously, linear means lines, non-linear is like a curve of some kind. And it can be like a compound curve, where it's like it starts out low and then it comes back up, or there's lots of options for what it can be. So we'll need to look into that for now. For now, what is our chapter called? Linear optimization models. So we're only going to be working with lines for now. So here's a list of typical applications. It's basically any time that you have a question that's too hard to solve, like in your head, or with a simple plug it in your calculator. If it's too complicated for that, then you've got yourself an optimization model. Okay, so here's our illustration. We've got a company called PAR Incorporated, which is a small manufacturer of golf equipment and supplies. There's the S. Management has decided to move into the market for medium and high-priced golf bags. So, maybe right now we're just selling cheap stuff or whatever, but we're going to move into medium and high-priced bags. So, presume that PAR's distributor has contracted with PAR to buy all of their produced bags by the end of the third month, and then they'll try to sell it for a profit. Okay, so, obviously we're trying to make money, but what's actually going on here? What are the processes that are involved? What are our decisions? What's the optimization model? Okay, so what is involved in making a golf bag? So we're looking at the manufacturing side of things right now. So what are the steps in the process? Well, in this fictional universe, there are 4 steps: cutting and dyeing the raw materials, so cutting the fabric and then dyeing it into the right colors. Sewing the different pieces of the bag together. Finishing, which is where you put in like an umbrella holder or maybe like some club separators or just like little plasticky bits or other things like that. If you play golf, you probably know what I'm talking about. If you don't play golf, then you might not. Doesn't matter. It's just adding in little doodads. And then step 4 is inspection and packaging. So, making sure it's in good condition and then packing it together and shipping it on. Okay, 4 major components. So they are organized by department: cutting and dyeing, sewing, finishing, and inspection and packaging. Now, remember, we're moving into 2 new products. We have a standard bag, which is like the regular, medium quality, and then there is a deluxe bag, which is obviously more complicated. And so you see these blue lines here are separating the 2 different bags, standard and then deluxe. The different bags have different hourly requirements from each of the departments. It takes time. So if you remember, we go back to the previous slide. It says our distributor will buy all the produced bags by the end of the 3rd month. So we have 3 months to make as many bags as we can, and then they're going to just buy all of them. That's our deal. So we're restricted by the amount of production time we have available. We need to make as many bags as we can, potentially. So, as you can imagine, most things are easier to do for a standard bag than they are for a deluxe bag, right? The deluxe bag is more complicated. So we're only going to need 7/10 of an hour, compared to a deluxe bag will take an hour. Now, 7/10, a tenth of an hour is 6 minutes, so 7 times 6 is 42, right? So 42 minutes versus an hour. Half an hour versus 5/6 of an hour, which is 50 minutes, 30 minutes versus 50 minutes. Now finishing a standard bag is actually easier because presumably it's, finishing a standard bag is harder. Presumably this has less going on, so you need to do more to make it a useful bag than maybe a deluxe bag, perhaps. We've already done a lot of the hard work, so finishing's pretty easy. And then inspection and packaging, it's very simple, so we're just gonna kind of good enough, slap it in a bag and chuck it out there. Does not have to be, go away, these notifications. I said no. How about no, Scott? Unbelievable. Okay. My phone is on silent. It's like muting their stuff, but it still pushes to the synchronization thing on my computer. Go away. Okay, as I was saying, very small amount of time for processing here for the standard bag, and still only 15 minutes for the deluxe bag. Okay, so that's what it takes. How much do we have? Well, we have an estimated total amount of time available in the next 3 months for the different operations. So we have 630 hours of cutting and dyeing, 600 hours of sewing, 708 hours of finishing, and 135 hours for inspection and packaging. Now, there's one other very important question we haven't talked about, and that is, how much money do we make for selling these 2 bags compared to what it takes us? So there's going to be some investment at the beginning, right? Cost of goods sold. And then there's also revenue, right? So how do these 2 things offset? Because of course, sure, you're going to get more value, more revenue out of your deluxe bags, but your costs are going to be higher as well. So sometimes actually you make less profit on the deluxe models than you do on the standard. So it's not obvious sometimes. It seems like, you'd be, I want to produce as many deluxe bags as possible. But look, we can make the standard bag so much cheaper. That we actually, even despite the lower revenue, we actually make more money. So we actually, in fact, want to produce more standard bags than deluxe bags if we can. So what matters, though, is that we will let the computer tell us what we should do. Okay, so now that we have discussed what are the processes involved, what are the steps in the manufacturing, and so on, we can now begin the process of translating these verbal statements into a mathematical statement, which we call a model, basically a series of equations. The goal here is this bullet point. Develop a mathematical model of the Par Inc. problem to determine the number of standard bags and the number of deluxe bags to produce to maximize the total profit contribution. Okay, so I want to go through this relatively quickly. It is important, and there's one thing in particular that is useful, but I also want to spend more time on actual practical than on the these kinds of theoretical details. This does definitely have its applications. My experience is that students don't grasp it at a level that it's truly useful to them most of the time in the short term. And really all we have is short term for this class right now. Okay, so here are your general guidelines if you want like a scientific method for making problem formulations, which you probably don't need. The most underappreciated one is the first one, actually. Understand the problem thoroughly. Sounds obvious. It's not that simple. It's always harder than it seems like it would be, which is why it needs more attention than people tend to give it. Anyway, so ask a lot of questions. From there, describe your objective and describe your constraint, and then sometimes, most importantly, define your decision variables. So what are your decisions? Why is that slide not showing? 10. 10. I'm not sure why the number isn't there. The whole idea, I'm not sure if you know what a slide master is. I feel like slide masters are really buggy, but maybe that's because people don't use them right. They don't use them correctly, and they break it. Maybe that's what happens. I don't really know. Anyway, so then you're writing your objective and your constraints in terms of the decision variables. Very important. So these constraints aren't super complicated. We have processes like cutting and dyeing, for example, and the number of hours that we plan to use must be no more than the hours we have available. Hopefully, that just makes sense, right? I need time, and I only have so much of it. Can't use more than I have. Sure. Hopefully that's obvious. And that's true for cutting and dyeing. That's true for sewing. That's true for finishing time. And that's true for inspection and packaging. Not complicated. So what are our decision variables? Well, we're going to make standard bags, and we're going to make deluxe bags. So why don't we use S and D for standard and deluxe? Sure, that's pretty straightforward. Okay, so then what's my objective function? Well, if I make $10 for every standard bag and I make $9 of profit, both $9 for every deluxe bag, then our profit is 10 times S plus 9 times D. Now, you may be asking, why do we care? Basically, we're going to build this into a spreadsheet, and you may not really need to think exactly about what these, like what is S, what is D, but you are going to need to make this part, 10S plus 9D, so it's not totally useless. But part of this is going to be an illustration of what's going on behind the scenes as the computer solves the model. Okay, so we have these constraints where we took those numbers from the table, 7/10 and 1. 7/10 times the number of standard bags plus 1 hour times the number of deluxe bags. Because remember, we have the same department working on both bags. So we cannot use more hours than we have available when you combine the production. So it's not just, I can't make more than, 7/10 times S. That cannot exceed 630. Both of them together cannot exceed 630. Similarly, a half times S plus 5/6 D less than or equal to 600 for constraint number 2. And then there's, more of this. 3 and 4 for your finishing hours and inspection and packaging time. I'm going through it quickly. In Excel, you'll only have to define the first one, and then you can use tables and formulas and stuff to kind of hand wave past the rest. Okay, but I do want to talk about this. Non-negativity constraints. So this is a bit of a sneaky one because it's obvious. It's so obvious that you forget about it. It's easy to assume that it's done by the computer by default, which it's not. And so that's called a non-negativity constraint. So if I ask you how many bags you want to produce, I think you'll assume that you cannot produce a negative bag, right? How many bags did you make today? Oh, -3. Did you create a black hole and it's gone? Did you set it on fire? What does it mean? How do you make how do you negatively make a bag? It doesn't make sense. You can't. You can destroy a bag, but actually making a black hole and destroying a bag or even selling a bag, none of those things are undoing the making process of a bag. Why? Because if they were negative, then they would be creating hours. If we come back to our other formulas, like this one right here, for example, if my S becomes -5, I uncreated 5 bags. If I'm Thanos and snap my finger with the Infinity Gauntlet, I've created now 5 hours of finishing time, basically. So not only is the bag gone, but I have 5 more hours available in the day than I did before. That doesn't make any sense. So we know that the number of bags, it could be 0, but it has to be at least 0. It could be anything larger than that up until the constraint is violated. So it's very important to remember that both S and D have to be at least 0. So put it all together, what do you get? We're trying to maximize our profit, right? We want to make more money, not make less money. So we're going to maximize 10S plus 9D, subject to, which is usually written in an abbreviated format, ST, all of these. And these labels over here are cosmetic. They're not required for the actual model. Cutting and dyeing hours, sewing hours, finishing hours, inspection and packaging hours, and our non-negativity constraints. Okay, so all of this is the mathematical model, which largely we do have to understand just to make the model at all. It's going to look a little different in Excel, but that's the idea. Now, the reason for all this is I'm trying to illustrate a couple things. One, this is a linear programming model, also known as a linear program, because, here's the key, the objective function, number 1, and all constraint functions are linear functions in terms of decision variables. So if you think back to algebra, linear functions have the general form ax plus b. But as we discussed earlier in our class, you can add additional variables, ax plus, we did like b0 plus b1 times x1, b2 times x2, and so on, right? So we can have multiple variables, x1, x2, x3, but none of them have an exponent. None of them are squared or cubed or to a half power or something. So if we go back, we shouldn't have exponents anywhere on the s's or the d's. Neither should we have s's times d's. So none of the s's can be multiplied by other s's or by d's, and d's cannot be multiplied by themselves by other d's or to the s's. So no multiplication of variables anywhere. That's what makes it linear. So specifically, another way of saying that is it's a linear function if each variable appears in a separate term, separate meaning separated by a plus or a minus, and it can only be raised to the first power, exactly the first power. No more, no less. The number of the exponent shall be 1. 2 thou shalt not count, neither count thou 3, excepting that thou erase it and put 1 instead. That's the linear programming as told by Monty Python. Okay, so we have now built the problem, and we understand what it is that we need to do, that we're trying to do. So I've talked about optimal, and I made my joke about the Foo Fighters and how it's the best of your options. It's very important that something truly be the best and not simply very good, because you'll hear the phrase more optimal, and this is just wrong. It is plain, pure, in fact, wrong. Because if something is more optimal than something else, then what that means is the second thing, the thing that is less optimal, in fact, is not optimal at all. Because either it is optimal, it is completely optimal, it is the best, or it isn't. It might be close, but it's just not. It's not the best. It's the, what is it, the Ricky Bobby, if you're not first, you're last? That's basically how optimal works. If it's not optimal, it's not optimal. Simple as that. So we're looking for the best solution. We want to know what the absolute best answer is, where we have the highest objective function value, in this case, the most profit. But of course, we can't violate our restrictions. We cannot exceed our constraints, which means that we have to have what we call a feasible solution. The answer we come up with has to be possible. So all of the settings for all the decision variables have to satisfy all the constraints. All decision variables and all constraints. So everything has to be all. So we can define all of what we call the feasible region, which is, we're talking graphically here. So if we make a picture, we can define all of our possible solutions, possibilities. And then we can find the solution out of all of our possibilities that gives the best objective function value. But we don't want to brute force, right? We don't want to try every single opportunity, especially on problems where we have a continuous decision variable. That would be literally impossible. It would be infinite. So we have to have a smarter approach to things. So in this case, we only have 2 decision variables, and the functions of our variables are linear. So assuming that our constraints are inequalities, any constraint will sort of draw a line through space. And it's going to cut the world, so to speak, into 2 pieces. We have one side that meets the constraint and one side that fails to meet the constraint. And we call these regions, these subregions, half spaces, because in theory the world is infinite and we're breaking the world into 2 halves of infinite pieces. And because they're both infinite, they may as well be the same size. So we call them half spaces, which I think is confusing, but I guess it kind of makes sense. So if we combine, we're going to make a bunch of half spaces using all of our constraints, and then we're going to lay them all on top of each other, and that will give us some weird shape that is the feasible region. And it looks something like this. So I'm sure that didn't make any sense if I describe it. But basically, you graph all of the constraints. Like this is finishing, for example. And finishing, if you make no standard bags at all, you can make as many as like 10, 50, I guess, deluxe bags. If you don't make any deluxe bags at all, then you can make as many as about 700 standard bags. And so you see that, the finishing constraint only limits this blue area on this little corner right here. You see this? Up here, sort of like a What is PPF? Price point feature, I'm guessing. I don't know. Give me a clue. Give me a hint. Did my chatty thing? Oh, yeah. That's exactly what this is. Production frontier model. Yeah. Okay. Isn't that a PFM? Whatever. Doesn't matter. Doesn't matter. Yeah, it's exactly like that. This thing right here, this outline is called the frontier. There's other names for it, but yeah, this is the frontier right here. So you're defining the frontier, the optimal frontier, or the Pareto optimal frontier. Again, there's lots of names for it. By laying all of the constraints on top of the same chart and seeing where what region successfully meets all of the criteria. So largely, all of the constraints have points when they're not useful, or in some cases, they're not useful at all. So it turns out that sewing is never binding the optimal solution, or is never binding the feasible region. Look, this line just kind of is just hanging out by itself, right? It's not doing anything. That constraint is actually completely useless and unnecessary, which means we could potentially reuse some of the hours. So if we've got some people scheduled over there that could be doing something else, we could move them. Yeah, so I'm not sure entirely what you're thinking when you ask the question, but the way that we find our answer is, the intercepts, our intersections are what define these critical points, these interesting points. So like this one, let me draw it on them. So like this right here, that intersection is interesting, that intersection, that intersection, that intersection, and that intersection. So we have these 5 points that are extreme points, is what we call them. They are extreme points, and it can be shown, and I won't try to demonstrate it today for time's sake. Yes, this is linear programming. It can be shown that the optimal solution is always at a production possibilities frontier. Sure, yeah. Same idea. This is exactly what that is. We can show that the optimal solution is always at an extreme point. So with these 5 things that I've circled here, one of those 5 solutions will definitely be the optimal solution. But without knowing the shape of the objective function, we don't know which one yet. So it is possible to graph the objective function and then hold a pencil at the right angle and then move it around the chart and find the best extreme point. But that is, which is basically what this looks like. So you can graph the profit line and then lay it across your feasible region and move it to the side. And then, the most money I can make is right here. So this is effectively the graphical way of finding the solution. So hopefully that illustrates the concept of what we're doing. But it's not at the end of the day, the easiest way to solve the problem. But it is sort of it's the motivation behind the math that Excel is going to do for us. Okay, so how do we get Excel to make our life easier? That's what this is all about, right? We want Excel to do our work for us. So how do we do this? Well, we have to start out by building a relevant what-if model, which is what we did in Chapter 10, and it's why we did Chapter 10. We have to start out by building a what-if model that allows us to try different values for the decision variables and see 2 things. 1, is that solution feasible? Do we violate any of our constraints? And 2, what is the value of the objective function for that supposed solution? And then we convey to Excel, this is a function called Excel Solver, not to be confused with Analytics Solver, like Analytics Solver Platform. It's totally different. This is regular Excel Solver. We have to convey to Excel the structure of the linear optimization model. So it'll kind of let us see with our eyes the value of our constraints and stuff, but we need to put that into terms that Excel can understand so that it knows what it can and can't do. So I have a model for us that we're going to take a look at, and this is on D2L under data files. Of course, we're in chapter 11 now. I need to upload the chapter 12 as well. Chapter 12 data files. And we want par.xlsx. Okay. So I'm going to give us a second while you guys pull this up. But I'm going to go ahead and tell you. So because this is an introductory model, my head's on the way. Okay. Because this is an introductory model, we've gone ahead and supplied you with a completely built out what if model. So you see we have the title, par inc, we have our section for the parameters, we have our section for the model. So we have, here's our operations, cutting, dyeing, sewing, finishing, inspecting, and packaging. We have the data for what all of these numbers are, which you see they're displayed in decimals, but the actual equation, if you look up at the top, is a fraction. So you can type in like 5/6 the way it was given in an equation, and it will display as a decimal. Very useful. We have available hours for the department. Yeah, par. That's it. Just par. See, par. And we have the profit per bag. So this is all of the data that we need for our model. And then generally, you want to type in a very basic, easy to understand example problem when you get your model built, because you want to make sure that everything's working properly, and so you want to be able to do one you can do in your head. So here's a good example. One of each. So, okay, so I've got my profit. So how much do I get for a bag of a standard bag? $10. How much do I get for a deluxe bag? $9. So total I should have, everybody with me? $19. Good. My profit function is working. Now, if you look here in the formula, what is it? This is a sum product, what we learned last time. Sum product of these times these, that is total profit. Okay, now how about my my constraints? So again, remember, I'm only allowed to use 630 hours, which by the way, we usually, out of convenience, want to move the values of our parameters down to the model here. It will make your life a lot easier later, I promise. But because we want to separate the parameters from the model, we don't want to type them in down here. So you see, look, what do I have in my formula? Equals D5. Equals D6. So we're pointing our formulas up at this region. So we type them in here, and they automatically update down here. We don't want to risk coming down here and breaking a formula on accident. And then we need to compare what's available to what we actually did. So with our example solution, 1 and 1, we should have used 0.7 hours of cutting and dyeing from the standard bag, and then 1 hour of cutting and dyeing from the deluxe, for a total of 1.7. Similarly, we should have, why is finishing 708? Ooh, it shouldn't be. It's not. What are you talking about? It's not 708. Good catch, Fabi. Should be 708. So the point is that we're eyeballing to make sure that our formulas are working properly. And of course, with a small solution with 1 bag of each, we're obviously not violating, right? 1.7 versus 630. I think we're fine. We are not about to violate our restrictions. Now, if we up the ante a little bit, put in 100 of each, and then actually have our formulas set to work, not that one. Okay, then 170 hours, 133 hours, 167 hours, 35 hours. We're getting closer. I'm just going to slap in some numbers. Okay, still good. Haven't violated anything. Our profit's going up, and so on. Okay, well, I could sit here and guess and check for a while, but really this isn't going to do me any favors. So, we're going to use Solver. Now, there will undoubtedly be some of you for whom this does not load and appear by default. And if that's you, it's okay. We'll find it. So, let me... Up on the house top. So this is the data tab, by the way. Data tab. There's a button called Solver. Now, if you're on a laptop, which I am assuming pretty much all of you are, oftentimes the Solver button will not fit this grouping. It's on the far right. It will not fit on the screen. And so it will appear as simply the icon, the blue question mark with the arrow going to the right. This is all that will show up. The word solver won't be there. Similarly, the words data analysis won't appear here either. You'll just have the symbol, which is a grid with a little box in front of it. So if you don't see the analyze grouping, that might be why. I think the cutoff tends to be around 13 inches. If you have a 13-inch laptop, it might fit. Otherwise, it probably won't, unless you have some of your other groups turned off. So it might be that it's simply not here at all. So I don't know if that's anyone. It's almost certainly someone. So I'm going to show you the process of how to get it. Natalia's got it. Good. If you don't have it, then what you do is you're going to go to File. You're going to go to Options. You're going to go to Add-ins, which might take a while to load. Then you're going to go to Go. And then right here, Solver add-in. I'll zoom back in so you can... Well, I said that. Come on. Yep, so you can see. So you should have, when you click Go, not OK, you click Go, it'll pop up, and there's a Solver add-in option, and you just check the box and click OK. Now, sometimes you'll get a little glitch, and it'll be checked, but it won't show up. So you can uncheck it, click OK, and then go through the process again. Yes, Antavis, all my lectures are automatically recorded and updated. So add-ins, go, check the box, hit OK. Yes, I record all the videos, all the lectures are recorded and posted, and all the ones we've done so far are already there. So just have a new one. Okay, so we have 13 minutes to talk about the Solver dialog box. So if you don't have it, follow those instructions, and you can finish the last 10 minutes of lecture on your own time. So where are they posted? On D2L, in links to online, I think it's online learning resources is the module, the first one, and then there is like VODs, I think it's called. Right, online learning resources, online lectures, right here. So here's the first four, and I'll add a new one that says linear programming. Part 1. Okay, so I've done you the favor of providing a completed model. So this is the complete correct answer. Now, because I want to go through the process of actually filling it out, because in real world when you do homework and stuff, it won't be complete. What you're going to do, so we can have a model to work with, click on this Reset All button. There's like 3, a gap, and then 2. Click on Reset All. It'll be like, hey, are you sure you want to do that? For obvious reasons. Normally you don't want to do this. And then click OK. Everything will clear out. All right. So there are basically 3 or 4. Usually we don't use this box. So there's 3 main boxes that we need to fill out. The objective, the variables, and our constraints. So the easiest one is the objective. So here's the first one. I make sure my cursor, I have clicked in this box, and then I'm going to click on the objective cell. Now, objectives are almost always something that are either profit or cost, but it can be like risk, or it can be, exposure, or, whatever. There are other options, but usually it's profit or cost. If it's profit, we want more of it. You like it, you love it, you want some more of it. Whereas if it's cost, you want it to go down. You want less of that. You want it to yell timber because it's going down. Okay, so because there's 3 boxes, students often skip this radio button. So you really have 3 boxes and a button to check. This is very important. All right, you hear me? You're gonna forget. Everybody forgets at some point. Don't let it happen to you. Our objective is profit. What do we want? More profit or less profit? More profit. We want more profit. So I want this to be maximized. Whoa! I forgot that if you double click that, it loaded. Yeah. So I'm choosing max. Now that's the default, so I don't actually have to change anything. But if I did, I might click the radio button. So make sure, step 1, pick the objective. Step 2, choose max or min. Step 3, change variable cells. These are the decision variables. So what are our decision variables? They are the bags that we are producing. Standard and deluxe. So all you have to do, click on the thing and click and drag. While you're clicking and dragging, the box will like magically go away. Don't worry about it. Objective is B16, total profit. Right here. Okay, decisions are changing variable cells are B14 through C14. And lastly, we have subject to the constraints. What are our constraints? Well, actually, we only have 1. It sounds like we have 4, right? Cutting and dyeing hours used has to be less than cutting and dyeing hours available. Sewing hours used has to be less than sewing hours available, and so on. But actually, it's just one major idea, right? Our operation hours must be less than the operation hours available, right? It's one major concept. Excel is smart enough that if we have them side by side, we can just click and drag and grab them all at once, which is really handy. So we're going to click the add button because we need to add a new constraint. I'm going to delete that for the mic. Okay. So we need to add our cell reference. So something has to be restricted to being less than or equal, or greater than equal, or greater or less than. There are lots of possibilities, but we have this number, this group of things. So I'm clicking and dragging on this region. So I have one cell reference right here. This group right here must be what? How is this group related to this group? Well, these have to be, let's check the right box, less than or equal to the hours available. Less than or equal to. Yeah, so it's very important. Stop and think. Make sure you get the right one or the whole thing will explode, metaphorically. So we've got B19 to B22 in this part. I'll go ahead and zoom in for us so we can check it out. B19 to B22, less than or equal to C19 to C22. And then we click OK. Now, if you're going to be entering multiple multiple constraints, you can keep clicking Add. That was a button that was an option for us. And Add basically means save and make a new constraint, whereas OK just means save and quit. Don't make any more constraints. And that's it. That is, I'm not sure I can get it exactly to show. Yeah. So we've got B16, max, B14 to C14, and B19 to B22, less than or equal to C19 to C22. Now, there is a box right here that we want to make sure is checked. It will generally be checked by default, but not always. You always want to pay attention. Make sure it's checked if it's appropriate. Again, what does this mean? It means we cannot produce negative bags. We have to make, so we don't actually have to put that constraint in here. We can just say variables are non-negative. So that will allow us to not have to make a new constraint. We can just leave it and it won't make any negative bags. Now, selecting a solving method, we are doing linear programming. So we want to choose the simplex linear programming method. So just hopefully this is the default, but we do not want to choose nonlinear, and we definitely don't want to choose evolutionary. Make sure we're selected to simplex LP. When we have done all of this, we want to come down and click the magic blue button, solve. Let's appreciate it in all its glory. Boom! Just like that. An optimal solution. Tell me that's not easy. Okay. You click a button. Magic. I love it. It's incredible. It is so nice. Sure, you have to go through the process of building the model. You got to type in the constraints. But let me tell you guys, when you get the hang of it, it goes pretty fast. And then you just get optimal solutions. Just like that. Perfect. Optimal solutions. Absolutely incredible. Life-changing, really. I mean, it is just powerful. It is. This is the jackhammer of spreadsheet tools. I mean, you just bust up a hard problem, man. I'm telling you. That's what it is. The jackhammer of spreadsheet tools. This is so cool. And it's free. It's built into Excel. If you have Excel, you have Solver. And by the way, you're a student, so you get Excel for free. If you didn't know that, you can get it. You can get all of Microsoft Office for free through the university. You have Excel. You have Solver. Where is the information that was solved? Well, so first of all, I'm going to click OK. If you click this Restore Original Values, it'll undo what you did. We don't want to do that. Keep it on. Keep Solver Solution. Click OK. And looky here. We have a new optimal solution, meaning we're producing 540 standard bags, 252 deluxe bags, with a total profit of $7,668. And while we're at it, let's take a look at our constraints. So we have two constraints that are less than their original values, meaning that less than the constriction. These are both less than the constriction, and these are equal to their restrictions. So just for fun here, and you obviously don't have to do this, I'm going to label these as... I'm just kind of highlighting them. You don't need to do this. In fact, I would not do this in real life, but just for the sake of the illustration. So we have two constraints that are unconstrained. These constraints are not binding, we say. They are not being limited. Inspection and packaging has some extra time left over, and so does sewing. But cutting and dyeing and finishing are both at capacity, which has several important implications. First of all, you generally don't want to schedule your employees to be working at capacity for 3 months. If anything goes wrong, you're screwed. You don't want to do this. But also, this tells you that if you could get more cutting and dyeing hours, if you could get more finishing hours, you could make more bags, and therefore you could make more money. Where would you get those hours? By taking them from sewing or inspection and packaging, perhaps. So it gives you a direction to start investigating, or it tells you where you should start looking out for problems. So this is of course an introductory model. This is in a sense as simple as it gets, and it's just going to get more complicated from here. But what that means is that we can solve more and more complicated problems, which means we're asking more and more interesting questions. Yes, cutting and dyeing and finishing are working at capacity because the numbers are equivalent. They're both the same. They're in harmony. They're balanced, or whatever. They're binding constraints is the industry term. They're binding constraints. So I think So the slides have like some screenshots. Here's the formulas. Here's what the solver dialog box looks like. So we can go over any of those. And by the way, we found some of the same results that we found in earlier figures. And there are some cool answer reports and stuff. And I guess we've got 2 minutes. Let me look at that real quick. So there's this, wrong thing. There is a cool thing called the answer report. And I'm just going to pull it up. The way that you do that when you solve the problem, there's an option over here that says reports. And we're going to click on answer. I'm going to make sure that's highlighted. You can toggle it back and forth. Sensitivity is also useful. That's beyond what we're doing today. I'm hoping we get to that on Thursday. But for now, just look at the answer report and click OK. So make sure that's highlighted, answer, and click OK. Now, the answer report appears as its own tab down at the bottom. and it does not automatically take you over there. It leaves you on the model, and so you have to click over to answer report. And so we were looking at those constraints. So, okay, it gives you, ignore all of this, by the way. Don't look at any of that. I'm just deleting it. I don't care. Okay. Profit, 76.68. Okay. Bags produced, 540, 252. Cool. Aha. Here's the interesting thing. Here are our constraints, which the name, I believe, is pulled from the label to the left. I have to go back and look at exactly how that works. But it's pulling the name of it may be, or is it a named range? No, it's not a named range. Is it a named range? I have to go look at the, it might be defined as a named range. We can talk about that later. But more importantly, here's the formula. We can tell what it is. And then it's labeled as binding or not binding. So if you see a slack of 0, that means binding. If it's not binding, the slack will be more than 0. And that will tell you how many extra hours you have available, which might tell you how many you can afford to, take away or add somewhere else. So this is a kind of a handy report. It can make things a little easier to read, especially on complicated models. But if your model is designed well, cough, cough, then you probably don't really need the answer report. I never bothered with answer reports when I was an undergrad or working in industry. I would just read the spreadsheet, but it's up to you. That might be something that's convenient if you want to mess with the name ranges and stuff. I want to check if that's actually how they did this. Isn't it under data? Where is it? Why is it in formulas? Okay, yeah, it's not a named range. So I think it's taking it from the list from the side. I don't actually remember how that worked. But I can toy with that later and figure it out. But what's important is that you have these statuses right here, and you can figure it out from this is the reference that the constraint is coming from, B19 through B22. So those are these right here. You can figure it out from there. So it's another way of looking at your answers. But that's it, folks. That's all we have time for. It is 5:30. So thanks for tuning in. Thanks for paying attention. Got some good questions. Announcements on D2L are not loading for you. Have you tried just downloading the file directly? That works sometimes. Is there a bird in my house? What? Okay. Where are those videos posted? Thank you, Jessica. That's it. Have a nice one. Stay safe. Please think about the exam. I will. I'm going to put it in the chat for you. Content. Online learning resources. Online lectures. And just for fun, can't download. It just says view topic. Does it look like this when you load it up? Like, does it do the thing? Maybe you're not. Hold on. Are you clicking on the arrow or are you clicking on the actual word? Because you should. So you should be able to. No, you're right. It's not set to open as an external. Okay. All right. How do I forget how I do this. Cannot connect to Google Drive. That's not ideal. Let me check the permissions. .googe. Drive.googe. Try logging in with your Google Drive and make sure you're logged into your InMail account. It shouldn't matter. I'm pretty sure I have it set to have unfettered access for all permissions, but anyone with the link can view. Anyone with the link can view. It should work. Maybe try Try logging in with your InMail account from Google Drive and then going back to the link. Try a different browser, maybe. Maybe that's the problem. Or I can... here's another... Well, no, that shouldn't matter. You could try. I don't think it would make a difference, but you could right-click, copy link location, and then put it up into your browser and click. That didn't do what I expected. That's interesting. I thought it would tell you. The link if you clicked on copy link location. It's actually hiding the link. That's really interesting. That's unnecessarily complicated, but I'm hearing the tweeting again. Did a bird get in my house? Oh, I bet you it's coming down the chimney. That's probably what it is. I mean, I can. The other option is you can open the video, the YouTube video, and just look at the announcements because I've showed them for several minutes on screen. Assignment due on Thursday. Chapter 10 homework. I'm going to cut the video there. If you're watching the video, the replay, thanks for checking in. Have a good one.